All right, we do want to start our chapter on logic here. And logic is basically it's a study of statements and their truth values. Yeah, in logic, they break it down, and you break everything up into a statement. And by statement, we mean anything that can have a true value or a false value. And it doesn't have to be always true or always false. It can be true here sometimes, false sometimes. But that's what we're studying in logic is statements. And their truth values, and then we'll get into statements, compound statements, and all that good stuff. But yeah, a statement, just to define it a little more again, it's a declarative sentence that is either true or false, just can't be both simultaneously. Because if it's that, then that's a bit of a problem. Okay. Yeah, we want it to either be true or it to be false. For example, the statement, today is today it will be 90 degrees. Okay, well, maybe false today, maybe true today. Just, it depends on the day. That's what we're saying. It can be one, can be the other. Just won't be both as simultaneously, right? There will never be a day where it's both 90 and not 90. Okay, so yeah, that's what we're getting at. What we'll try to avoid is statements that don't have true or false values. Like if I made the statement, paint the room. Okay, that's not true or false, right? Paint the wall, that's a command. So we're talking things that are true and false, and then we also we want to try to avoid statements that are they kind of have opinions, or like the statement "Tiger is better than Jack." That depends on somebody's opinion. So we want to kind of be factual about it. And anyway, okay. So that's what we're studying. Which may not sound like, well, that sounds easy, but there is some things that go along with it. All right, and I mentioned the idea of compound statement. Well, that's just what it sounds like. A compound statement is a statement that has two or more component statements. So a compound statement is two or more statements joined together by connectives. And a real good example of that would be the famous statement, roses are red and violets are blue. Well, that's two statements, isn't it? Roses are red and violets are blue. Two distinct statements, and they're joined together. Well, there's our word "and" again, so there'll be some connections here between the sets, and because we're talking about "and" "or" statements again, because you can do the very same thing with an "or" statement, couldn't you? You could put two statements together with an "or" statement. And so, yeah, those are the two types anyway that we'll start with, the and or statements. We'll talk a little bit, a lot about those as we go here. Now, a couple of notational things. When we're working with these, we've got our statements, but a lot of times we'll want to denote statements with an abbreviation, and the way we'll do that is with just lowercase letters, P's and Q's. Let's say our roses are red is the P statement, and the Q is the violets are blue statement. So letters representing statements, no big deal there. And then also, notationally wise, the and statement is represented by this symbol. Looks like the tip of an arrow, maybe. That's going to be the and. Kind of looks like a capital letter A without the little bar, but that's and, what and will look like.
So it's no longer the and?
Right. Yes. In set, so yeah, the connection there. In sets, you got the arch, or the N shape, but in logic, it's the arrow tip type thing. So why does it change? I'm not exactly sure, but that's what they do in logic. I guess logic wanted its own symbol for and. It didn't like sets. Okay. No. It's just slightly different. Okay. We can do the very same thing for the or statement. If we have a P or Q statement, well, notationally, we could the or will be represented with the V shape, just like the or in sets is the union, the flip of that, and same thing here. Okay? One other little bit of notation, they may ask a question about it. And statements are known as conjunctions, and or statements are disjunctions. And are conjunctions, and or statement is a disjunction. They may ask about that terminology, but that's all. And is conjunction, or is disjunction. Okay? All right, so we'll get back to and or a lot more in a moment. But right now, let's talk about negations. It's really a very simple idea. The negation of a statement P, the negation of P is being a statement, the negation of P is the statement that has exact opposite truth value. So the negation of P is a statement that has the opposite truth value in all cases. And that does need to be said there, in all cases. Okay? Now, usually it's easy enough to negate a statement. Well, let me mention the notation. The notation for the negation of P is the little squiggly line. So if you see that, that just denotes the negation of P, the opposite truth value. Squiggly P means negation of P, the opposite truth value of P. So that's our notation for it. Okay? Now, like I was about to say, negating a statement is usually pretty easy. You usually just have to put the word not in or take the word not out, something like that. Like Today is Wednesday. If I want to do the negation, say that's my P statement. So the negation statement, negation P, well, just put the word not there, right? Today is not Wednesday. And that's the opposite truth value, isn't it? Today is Wednesday. Well, if it's on Wednesday, that's true. Today is not Wednesday would be false. Now, if I go, now here's the thing. Would this be, because sometimes there's more than one. Let's do this. Is that a negation? Today's Thursday? Well, if today is Wednesday is true. Today is Thursday is false. So it's opposite. However, it's not opposite in all cases. Today is Wednesday. Let's say today is Friday. We go to the day of the week being Friday. If I make the statement today is Wednesday, that would be false, right? If on Friday I say today is Wednesday, that would be false. Today is Thursday would also be false, right? It's not a negation. That's why we're saying in all cases. It may be opposite in some ways, but we want it opposite in all cases. If I'm on Friday and I say today is Wednesday, that's false. Today is not Wednesday is true. So it's opposite, you see, in all cases. So not probably an issue there, but I just wanted to make that clarification or that point there. Usually just put the word not in appropriately and you got it. Okay. All right, so let's change it up. Let's go back to let's say it P is it will be 90 degrees. Q is it will rain. Those are our two statements. All right. What's this then in symbols? It will be 90, or it will not rain. What would that be in symbols? Well, this is what? P? Or, what symbol is that one? Or is in logic, it's the V. And it will not rain would be, what would that be in symbols? Well, that's the opposite of the Q, isn't it? So what would I write? Squiggly Q. Okay? So it's not anything difficult. It's just knowing what the symbols mean. And okay? All right? What would this be in words? Squiggly Q, then this one, squiggly P. What would that be in words? Well, squiggly Q is the opposite, the negation of Q, so it will not rain. And then this symbol, well, that's the and. Like I said, it looks more like an A than the other. And not P is the negation of P, so it will not be 90. Okay? All right, so like I said, it's not anything difficult yet, but just so you know. All right, now, just a real quick little note here. If I write this one in words, for now, here's what we're going to do. Say it's squiggly, parentheses, P, then the V, and then the Q. Again, we run into the issue, you do the inside first, and then, okay. Well, the inside is, we know that's P or Q, so it would be, it will be 90. Or it will rain. But then we have the issue of the squiggly. What does the squiggle do? It negates it. So to negate this in this case, here's what I would say. I would just say, it is not the case, just to kind of phrase it, that, I ran out of room, didn't I? It will be 90 or it will rain. Okay, that'll suffice for now. Okay, we'll talk about things a little more in detail later on, but another lecture. But so yeah, just for that squiggle in that case, to negate the whole statement there, just say it is not the case that it will be blah blah blah. Okay. All right. Here's another little issue about negations. Turns out to negate what we call quantifiers, words that have quantity associated with them, like some, all, none. We should talk about a few things, because negating those, a little more tricky. Usually, you put a word not in, you got it. And it's the same for one of these quantifiers, but let's talk about it.